A quick example that I wanted to look at for how to do some graph interpretation stuff. So we have this graph. Now, anytime we look at a graph for things in this class, it's going to be pretty much safe to assume that what we can see, especially if it's a graph that I'm giving you for some reason, it's going to be safe to assume that we see all of the interesting things that happen, and that as the graph leaves the the part of the plane that we can see, that it just, as we talked about in class, continues doing what it's doing already, right? Now we'll talk about when there are maybe exceptions to that or when we need to be a little bit more careful. But again, if I'm giving you a graph or something, we can assume that we see the important stuff. So we want to use this graph to answer these questions. Is this a function? What are its domain and range? What is f of 2? And when does f of x equal 6? So first, for the question of if this is a function, keep in mind being a function means that every input or x value or possible value for the independent variable, so any element of the domain, maps or is paired to exactly one thing from the range by the function. So what that means graphically is that any x value I go to, if I think about, sort of looking straight up or straight down, I want to know, would I see the function somewhere? And in order to be a function, I need to see it only one time. So, for example, if I'm at 4, there's a point, you can't see, but I'm gesturing up above the part of the graph that we can see. There's a point up there where this thing crosses because one of those ends is continuing to the left. And if I, sort of think about that for all possible x values, what I want to see is that at any possible x value, it only crosses the graph one time. This is called a vertical line test. The idea is that if I could draw a vertical line somewhere that hit the graph twice, or more than once anyway, that would be a place an x value where we've got more than one y value corresponding to it. I see that that doesn't happen here. So is this a function? Yes. Passes a vertical line test. That tells me that it is a function. So the next question would be to find the domain. Domain is all of the x values. So again, along the same lines of what we just talked about, I want to look for x values and think about whether the function would pass through those somewhere. So if I was standing right here somewhere, then I know that there's a point up here, right? It's off the visible part of the graph, but there's a point up there that this graph passes through because this end is pointing to the left. And in fact, the same thing is true anywhere if you want to think about sort of taking this graph and squishing it down, right? Sort of flattening this thing out. The part that we care about is that this is pointing that way and this is pointing that way. There aren't any jumps or breaks or gaps in what we see in the graph. So what gets included then in the domain, if I was going to sort of shade it like a number line, would be everything. Right, we continue to the left and to the right. We pass through everything in between. The domain then is all real numbers. Or if we want to write that, I don't know how to make an S. There we go. Or if we want to write that in interval notation, we could say negative infinity to infinity. For the range, we do the same thing, but we consider the y values. So first of all, I've got these ends pointing up, which is going to be in the direction of positive infinity for y values. And everything all through here is included in the range as well until we get to 2 because that's the minimum or the lowest point on this graph. So if I was shading this in, I would shade it something like that. It's everything from 2 up. The way we would write that as an interval is 2 to infinity. 2 is included, so I use a square bracket to show that that side of the interval is closed. Okay, now evaluating the function. What is f of 2? 2 here is the input or the x value. So what I want to do then is go find x equals 2. There it is. And again, sort of imagine myself, standing there and looking for where the function passes through that point. When x is 2, I see the point 2, 3 on the graph. So the y value that goes with it is 3. F of 2 then is 3. This last question, when does f of x equal 6, is the same idea, but in reverse. So we're starting with a y value and looking for the x that goes with it. Oh, sorry, maybe I'll just write in that 3 is a y value. So I'm starting with a y value of 6. So I go find 6 on the y-axis. And again, I'm looking for the function. Now, when I look across at 6, I see this point at 3, 6. But don't miss the fact that there's also another point at negative 1, 6. So to answer the question, when does f of x equal 6? It happens when x is negative 1. It also happens when x is 6. Now that's one y value that matches with two different x values. That's okay though. That doesn't prevent it from being a function. That's related to a different property that we'll talk about later on. It is, important sometimes, but it doesn't prevent it from being a function. This is just, to use like our vending machine example, this is like having two buttons that do the same thing, right? The input negative 1 gets me to 6. The input 3 also gets me to 6. That's okay. That doesn't prevent it being a function. Okay, that's it. Please let me know if you have any questions.